So this is the first one of our lunch webinar series from the CSE Edmonton 2021 to 2022 season. We're still continuing with our evening presentations on the third Thursdays, and then our lunch series will be on the first Thursdays of each month going forward. So the presentation today will be on the Sundance Housing Co-op Deep Energy Retrofit by Peter Amerongen. To begin, we'd like to give a thank you to our sponsors from this season. In no particular order, we'd like to give thanks to RJC Engineers, PCL Construction, Dam Galvanizing, ISL Engineering, BP Tech, McElhaney, WSP, Qualamet, Matrix Solutions, Salmon Inc., Dialogue, Wood PLC, Altera Engineering, Northwest Hydraulic Consultants, U of A Steel Center, Claystone Wastes, Cerber Engineering, Alberco Construction, AECOM, Morrison Hirschfield, SEMA Plus, and Associated Engineering. Along with the lunch webinar today, we also have a scheduled site tour for the Sundance Co-op location in the heart of Edmonton here. This is scheduled for October 20th at 5:30 p.m. in the evening. We'll send a link. Oh, do you see my current slide here on the upcoming site tour?
We're still on the housekeeping rules.
Oh, Let me stop share and I'll reshare here.
There we go.
Ready? Is everyone able to see the sponsor screen here?
Yes.
Thank you. And then onto our upcoming site tour. So we do have the event up right now. It's scheduled for the evening of October 20th at 5:30 p.m. We'll paste the event link into the chat so people can see and register as well. And also our next webinar presentation will be on the evening of October 21st, and it will be on the Vancouver subway system. As well, we've just released our season poster, and you can find the poster link on our CSE Edmonton website. And this shows the schedule of our upcoming webinars and presentations. For 2021, we will be keeping everything online, and then we'll think about moving back into in-person dinner presentations during next year, depending on the current regulations. And moving on to today's featured lunch presentation, it'll be on the Sundance Housing Co-op Deep Energy Retrofit. And a little intro on Peter. Peter Amerongen has been designing and building energy efficient houses in and around Edmonton since the 1970s. And as a partner at Habitat Studio, he has also designed and built net zero energy houses and led Canada's first net zero affordable multifamily project and Canada's first net zero energy church. In 2018, Peter has joined Butterwick Projects, and he has led the Sundance Housing Co-op panelized deep energy retrofit. He is also a consultant with Renew Engineering, where he helps builders develop practical, affordable, low carbon building solutions. And Peter is an original member of the Edmonton City Council's Energy Transition Advisory Committee and also CHBA Net Zero Council Management Committee. He is also certified passive house consultant. And with that, I will pass it over to Peter.
Is that okay? Can you see that?
Yep, I see it.
Thanks very much, Frank. So just to, but before we get into the presentation itself, I'd like to just quickly go through the context. As Frank mentioned, I'm on the city's Energy Transition Advisory Committee. This is a slide or graph showing where we need, the kind of cuts we need to make to keep Edmonton within a 1.5 degree scenario budget. At the rate we're going to blow through that in the next 8 years. So, and Edmonton is not atypical. We're seeing graphs like this all over the world. And buildings are responsible for about 40% of total GHGs. And 70 to 80% of those buildings are that we'll be using in 2050 are already built. So there's really no path for a stable climate without industrial scale deep energy retrofits to existing buildings. And the Dutch have an interesting start on tackling this problem. They've developed a system called Energy Sprong, where they scan the existing buildings and make panels in a factory and bring them out, and within a matter of a month or so can transform existing 1950s post-war buildings into net zero energy buildings. They've done about 5,000. They're about 10,000 in the works right now, and their pilot project was 110,000. So the Sundance Co-op, it was built in the 1970s. They were on the verge of renewing their mortgage and their lease, and they realized that this would be probably the only chance they would get to upgrade these buildings for the long haul. They're interested in the next 50, 100 years. It's a very stable community, and they're interested in basically leaving these buildings in good shape for posterity in every respect. So we're now currently on building 6 out of 15, but they started with a building condition assessment, found that the buildings are basically sound and worth upgrading. There's some maintenance backlog, but nothing serious. So they had Renew Engineering do an energy model and then combined it with cost estimates from Butterwick to present several scenarios. And the initial costing came in around $5.4 million and showed an approximate payback of about 30 years. And while the co-op was thinking about that, we found out about an R&D program with Amerongen that and scrambled together and put a proposal in to do an Energy Sprong type retrofit to the co-op, and we were successful in that application. And the $2.5 million that came with it made the co-op's decision a whole lot easier. So and I can tell you they're getting their money's worth. We started with some pretty complex buildings, especially considering what they're looking at or what they're doing in the Netherlands. And I got a tour in 2019 of some Energy Sprong projects there, and I showed my tour guide these photos. I said, Simon, so what would you do with these cantilevers, these tight little jogs, doors that are too close to the corner to really have room for a panel, the porches, some anomalies from member-built additions, odd windows. And Simon said, for us, this would be a no-go. So we kind of knew we had our work cut out for us. And we started in 2019 with a pilot on a duplex. We did that one essentially on site. We built panels in the parking lot and went through the motions as if they had been imported. And we came away with a list of about 200 things that we thought we needed to improve. And that, some estimates as to the cost reductions that we would get from that. But it wasn't until we got in a few buildings that we realized the benefits of doing this one building at a time. The learning process has been ongoing and continuous. Each building gets a little bit better, a little bit faster. We're still not on schedule. It's taking us longer than we anticipated, but we're slowly catching up. So one of the critical things is a panel fit. And one of the things we've learned is that this is kind of a new kind of construction. It's not like a typical renovation where you would just build to what's there. And it's not like new construction where you've got a set of plans and you build it kind of in the fresh air. The panels are built off-site weeks in advance, and they need to fit buildings that aren't level, not square, not plumb. And one small mistake can really stop you in your tracks and negate the advantages of off-site construction. So we started with a LiDAR capture. Bernie Jess, a surveyor, did the first building for us, and we could see we were able to make it work. So then he surveyed, he did the whole site. It was 55 scans that are all registered together in one roughly 200 gigabyte file that was also calibrated to about 60 total station shots. So then he clips out each building and sends it to us as an E57 file. We brought that into SketchUp using a program called Undet from Lithuania that enables us to then extract the geometry one wall at a time from as SketchUp geometry. And of course, because the buildings aren't level, square, or plumb, the extracted geometry isn't orthogonal. So we need to judiciously fudge that to within the panel tolerances to get it orthogonal so we can work with it. And then we apply SketchUp elements representing the windows and doors and slide them over the point cloud till we get what looks to be the best fit. And it's kind of a nerve-wracking process considering the and remarkably it requires a fair amount of judgment, which not as magical as I had hoped we would be ready for at this stage. Anyway, once we have the basic building geometry, we divide it into panels and then detail the panels for framing, for sheathing, including the lift points and cellulose fill holes and the water resistant resistive barrier, and also what siding can go on and what needs to be left off to knit the panels together and get the cellulose into the cavity. And it's a amazing number of drawings. Like each building will have 20 to 30 drawings. We have about 20 pages of panel manufactured details, another 20 of site details, and another 10 pages usually per building of site instructions. So the basic panel is a lightly framed 2x4 panel just enough material and strength to carry the siding and hold the insulation and withstand the wind loads and the stress of handling and transportation. They're made at in a workshop offsite in Killam, Alberta, by our panel partners. They arrive with the doors, the WRB, the rain screen, and most of the siding installed. We tried to find a local prefab plant, but nobody was interested. We're just a little too far off of their standard offering to make it worthwhile for them. So while the panels are being manufactured, we're getting the building ready. And we start with taking off the old porches, and we then use a hydrovac truck to excavate a slot basically around all the buildings that we can install 6 inches of EPS insulation. And then we install a ledger and a panel support box that is hung off the ledger and designed to carry the panel load and the porches that go back on, and the roof, the additional roof overhang, and also the heat pumps that'll be going on. We'll see in a second. So really, the building prep is where an awful lot of the work happens. We we're slowly improving it. We're installing, we're enlarging the basement windows to meet egress requirements so that folks can have bedrooms down there. And we've got a number of penetrations we need to make through the rim joist area that are for HRVs, the existing hose bibs, dryer vents, that kind of thing, that are durable and airtight. And then in preparation for the panels, we loosen all the existing windows so that we can get them out quickly on panel day, and install brackets to tie them back to the building. And in many cases, we're having to, some of the windows that were installed in the 2000 or 1990s, when they did the first window replacement, didn't get headers. And we're also installing some new windows. So we make provision for those on the outside. So then comes the big day. Lots of angst about anxiety about whether these things are going to fit or not. And so far, they've all fit really well. We shrunk them all about 10 millimeters in width, or 10 millimeters in width on both ends, to allow us to slide the panels back and forth to get the best fit on the windows. We weren't allowed to shrink the windows by more than a few millimeters. The windows weren't any bigger than you would. In fact, if I were designing it, I would have made them bigger. So we really couldn't afford to shrink them. And so far it's been, we haven't used that 10 millimeters. We're just about bang on with them. So that's been a great affirmation of the process, and a huge relief. So the end result is a building that's very similar to what we would spec for a new net zero energy building. Roughly, we're adding R50 to the attic, R28 to the walls, R28 to the basement walls. We're not doing the basement floor. It was too disruptive to be working in there to do that, and also too expensive on a cost per kilowatt hour per year saved basis. The insulation gets blown into the cavity. It's cellulose. So very low carbon solution. Um, we've had some challenges with it and had to devise ways to essentially inject it way at the bottom to be able to get the pressure we need, and make sure that we design the air escape holes so that when we fill in underneath the windows that that we get it right up into the corners. But all in all, that it's working okay. We're you know, from our bag count and everything, we're getting what we need in there. Once the buildings are insulated, we knit together the water resistant barrier, which is also our air barrier. One of the big upsides in the retrofit is air tightness. The starting air leakage rate is about 3.5 to 4 air changes an hour, and we're getting it down in the 0.6 range. So that's it's probably one of the most cost-effective parts of the operation. And then the water-resistant barrier is behind a rain screen. So we start with a fiber cement siding, which is durable, and then make it even more durable with the rain screen approach. For the roofs, we're wrapping the existing. We cut off the overhang, wrap the existing roof with a poly vapor barrier. The poly is getting enough insulation over it that it's well above the dew point, and that gets sealed together with the WRB on the walls. We've got sensors in our pilot that show that our moisture levels in the cavities in the old attic and the new attic are all well within safe ranges. So we've also run into a bit of an issue with the siding. We're finding like we really wanted to do as much as possible in the before these things came to site, but we're finding that the labor involved in patching in the remaining siding is almost the same as what it would be to do it all on site. And when we combine the savings from the factory to not put it on, we're actually going to try on the next building to just install the panels with no siding and do it all on site, which has the advantage for us of being able to use a subcontractor then, so our own forces can get on to the next building. But it's kind of an emotional setback in that it was part of the plan, and they look a lot cooler when they go up with the siding. Anyway, one of the other huge learnings for us has been the problems of working on a site with 100 people who are staying in their homes. And this is a community that's very democratic, really kind of empowered, and so we really work hard at managing expectations. We start each building a couple of weeks ahead. We'll do a 50+ slide PowerPoint to let the residents know what to expect at each stage, who to talk to if there's a problem, and how we'll be scheduling it. We give them at least every week they get a week look ahead, and very often there will be updates in the middle of the week as well. So it's a lot of work. And inevitably there are, issues arise. The co-op has a group of just amazing volunteers that we work closely with, the Sundance Planning and Development Committee, and we just couldn't manage without their hard work and diligence in discussing and solving some of the issues that arise, and helping to keep folks informed and particularly dealing with the issues. It's a huge, it just would be impossible without them. And so our bottom line, on everything we do is always making life better. And we're really proud of the really crisp new look that the that we're giving these buildings, and the little touches that we're adding to make life better. For example, we're putting skylights in all of the porches. The kitchens used to be pretty dark, so they get a lot more light in the windows. Every living room, if people want it, gets a big sort of window seat, boxed out window. These are replacing, in some cases, crappy traditional bay windows that had been installed in the 90s. And of course, we're thrilled with the feedback from the residents who've been in their finished units. These units are warmer. They've got humidity control, and way more comfortable than they were. And it's yeah. So as part of it, because we've made the building so airtight, we needed to put in HRVs in every unit, and they're a critical component of health and getting that fresh air without paying a huge energy penalty. There again, it's taken some learning to figure out how to install these things laparoscopically without too much drywall repair and disruption. We got kind of a lucky break in that we found that we could actually vent the second story bathrooms by running the exhaust line up through the old chimney, the old B-vent chase. We were able to just lift them out and drop these lines in. So we've got one hole now on for the kitchen HRV, and way better than the pilot. So we're also replacing all of the existing furnaces and hot water tanks, which are fired with gas, with air source heat pump heating and cooling units, and hot water tanks. Basically the same appliances that we would install in a new net zero energy house. The heat pump heating systems are giving us a COP of about 2 units of electricity, two units of heat for every unit of electricity. On an annual basis, they would fluctuate from a high of 4 in the shoulder season to when it gets to be minus 30, they drop, the COP drops below 1, so they're tied to an electric resistance backup heater that takes over at about minus 25. So when you do the average based on heating degree days, it comes out at around 2. And the hot water heaters have a COP of about 1.8 on a seasonal basis. That's partly, they're stealing heat from the house in the winter to heat the water. So you've got to factor that in. In the summer, they give you a bit of free cooling, and all in all, it seems counterintuitive for this climate, but they work well, and they're a key part of the cycle. So abandoning the gas lines is going to save the co-op about $38,000 a year in fixed energy charges. So that in order to electrify, the original units had 60 amp service, And we need something like 120 amp service. The old system was considered obsolete by EPCOR and not upgradable. So we installed a completely new system using directional drilling, a new 600 volt single or three-phase transformer with a series of 5 distribution sheds, one to that's got the main switch and the meters in it, and then 4 remote sheds that each have 2 panels serving about 8 units each. And that's where the voltage steps down to 120, 208. So we had a big scare in the just before we were ready to start this. If we'd have gone with a single meter on that system, it would have put us in an industrial rate class that attracts a demand charge of about 48 cents a kilowatt hour. It's actually 90% of 48 cents a kilowatt hour year round based on the heaviest month, which would be the coldest day in January when we're using all electric resistance heating. It would have been prohibitive and wiped out any savings from all the conservation we're doing. So we were able to subdivide the co-op into 8 smaller systems, 2 in each shed, that get the biggest annual draw down into a rate class that is very similar to typical residential rates. But it's electrification is one of the key parts of adapting to climate change, and this is going to be a big issue for the utilities and building owners as we attempt to do this electrification. So in addition to, so the co-op wanted to be as close to net zero as possible. So they're installing a 350 kilowatt solar array that will provide about 75% of the total annual energy needs. And then they'll buy the rest from under an offsite renewable contract. So the costs, it's costing about $125 or $125,000 a unit, which may sound high, but compared to what they're doing in the Netherlands and a comparable project in Ottawa, it's substantially lower. We had hoped that we would get it down to more like 80 or 90,000 with repetition, but at the end of the day, it's got a lot of site work and it's a renovation project first and foremost. The panel costs are about 20% of that cost, and of that, half is the windows. So it's really, as we look ahead, we're anticipating further small wins, but it's unlikely that we're going to get it to where we wanted it. So the total long-term cost of ownership will be low. So the value proposition is energy savings, maintenance, catch up, and avoidance, and and some subsidy, I think, and to some degree, I think it's going to take a commitment to a more habitable planet. So the elephant in the room as we look at the landscape for doing this kind of work is really single family housing. In Canada, 8 million of our 14 million dwellings are single family houses. And the footprint from those is vastly bigger than from the, on a per capita basis than from multifamily. So we really need to crack this nut. And we're just starting another project working on 3 single family houses. This one is supported by SSRIA, which is large emitter carbon tax money. As we get into it, we're seeing that in some ways it's easier, in some ways it's harder, but I think it's doable. We're excited about it, and we're particularly excited about a different way of doing the geometry extraction. We're working with a brilliant young grad student who spent some time in the gaming world, who's developed a program using photogrammetry based on drone-based photos. He takes about 20 and uses about 10 of these photos. From the drone, he can get optimal angles for the geometry resolution, and he stitches these photos together, much like you would a panoramic photo, into a 3D cloud of pixels, and then calibrates that cloud based on 3 dimensions on each of 2 sides, so a triangle. And he's able to go to the far side of the building, where there's no measurements been taken, and get about 6 millimeter accuracy. So, and when we get it, it's all, he's used least squares adjustment to rectify the geometry and make it orthogonal. So it saves a lot of fooling around for us. And it's working well so far on this project. So we have also started an entity called Retrofit Canada that is dedicated to sharing the lessons from these 2 projects, and also other projects going on across the country. We're hoping to build a library of case studies that help other people avoid our mistakes and allow us to learn from theirs. And with that, it'd be great to have a discussion and any questions you might have. Thank you.
Thanks very much, Peter, for the wonderful. If anyone has any questions, feel free to unmute your mic. There was no questions in the chat right now, so if anyone has questions, please feel free to unmute your mic and ask away. In the meantime, I will paste the link here for the site tour we have scheduled at the Sundance Housing. I'm very excited to see these in person. One of my questions on this is, how many buildings did you guys retrofit?
So there are 15 altogether, and we're working on the 6th. So we hoped, naively that we would be able to do a building a month, but it's taking a couple of months per building. And as I say, we're getting a little faster. We have to be done by December of 2022.
When did construction start?
So we started in November of last year. We did the first pilot in the spring of 2019, and then it took us a fair while to get back to it. There were a number of issues we had to work through, including the electrification, and then COVID came along and slowed us down. And so we didn't really get back to construction until probably mid-November of 2020.
Oh yeah.
Hey everybody, this is Leslie here. I was typing my question, but it became a little wordy. I think you answered all my questions, Peter, with your presentation. The stuff that I wasn't able to find online about the project was mostly about the subsystems that are being installed to support that net zero achievement. I guess maybe it's just a higher order question, but you answered it too. You said it's really going to take a commitment to having a habitable planet to get the buildings upgraded. But I guess practically, do you see the path? Do you see a path? Is it like political path or?
I think it needs to be, we've left it so long that we really have so much to do in a short period of time, including figuring out how to do it. Like, I think with repetition, we'll get it faster and cheaper. But it is going to take big political will, I think, to make it happen. And I see hopeful signs of that. There's a lot of interest in this at the federal level. They really need to tailor programs to deep energy retrofits and away from the piecemeal incremental subsidies that have been prevalent up until now. The money that they put into the piecemeal subsidies, where you say get a few $1,000s to add insulation to your attic, or to replace your windows, don't help, because if you don't do this all at once or at least in a planned way as a systems approach, adding insulation in the attic without dealing with air tightness makes it harder to ever deal with air tightness. Replacing windows that are not of a quality that's needed to get into sort of net zero territory, or adding insulation that doesn't get you into that territory, means that work has got to be redone. And if you replace a siding as part of that work without dealing with these other issues, you really aren't going to get there. So they need to treat the building as a whole system, starting with an energy model and a kind of a net zero feasibility study before starting. So that's a tall order to retrain a bunch of energy advisors and mechanical engineers and people like that. When you look at non-residential buildings, in short order, like my hope is that with a few pilot projects and making those lessons available very, very quickly in real time, that will slowly will help other projects accelerate a little bit, and in the process build the capacity, because the capacity is not there. There are very few contractors who really think and in a way that would achieve the kind of results that you need. Part of our, the reason I think that we're able to do it is that we've got this experience with net zero energy buildings to start with, and it's not that much of a leap to apply that to existing buildings.
Thanks so much, Peter, and thanks for the presentation.
Thank you.
Thanks, Peter. There's a question here in chat from Louisa. Question is, how scalable are these retrofits? And how practical is it to do similar retrofits to a large fraction of homes?
Well, That's a good question. Not as scalable as I had hoped initially, but these are early days. Like we're just figuring this out. We're hoping that with repetition, it will become more scalable, that it will be worthwhile to build factories similar to, say, landmarks, where we've got enough throughput to justify a fair amount of mechanization. And also that will develop faster techniques and products to make the on-site work easier and faster. So, right. Yeah, it's hard. It's really hard to say. We just, our part of this process is just to do it and to solve the problems as well as we can. And we really are, it's a bit of a leap of faith, hoping that the infrastructure and the financing and that kind of thing will come along at pace, and also that the industry capacity will grow. And there are other people working on this. The CHBA is working with Canadian municipalities on training and qualifying retrofitters to do this on single family houses. And there are other people working on in the big building, and there's the Pembina Institute has got a reframed initiative that's doing pilot projects on some low-rise multifamily buildings, just getting ready to go in the next year or so, looking at various panelization techniques. So I don't know if that answers your question. It's going to be a challenge for sure, but like I just don't see any alternative if we want to maintain a habitable planet.
Thanks, Peter. There's another question in chat from Alicia that asks, Peter, you mentioned a portion of the energy comes from off-site renewables. What are these off-site renewable resources?
So several utilities, and I think in this case it's Foothills, aggregate off-site sources. And so it would be a combination, mostly wind, probably from southern Alberta. So you pay them for the energy you're using, and they're buying it from renewable sources, and you trust that they're doing what they're, I think there's a certification process that guarantees that it is. Like in reality, in terms of the electrons, they're actually still coming from the gas or coal-fired plant that's closest to you. But your dollars are paying renewable energy providers. Does that answer the question?
Yes, it does. Thank you.
I noticed on your agenda that you've got Gordon Howell coming to talk to you about solar somewhere before Christmas, and he would be the guy to ask about that for sure. He lives and breathes that stuff and knows really well how all the grid arrangements are set up.
Yeah, Gordon's really excited to talk about the solar topic as well. We have one more question here from Andrew. It asks, how can governments do better in encouraging deep energy retrofit?
Well, I think that they need to change the messaging somewhat, and we're in conversations with the city of Edmonton and city of Vancouver about how to go about that. But a lot of things have to happen. The capacity, the incentives, and the city of Edmonton is trying to do that. They're requiring a building as a system approach, at least the beginnings of it. You can't get the subsidies without an Energuide audit. So I would like them to take one more step and say, have the auditor, spin the dials in the model and say, okay, this would be what I'd recommend for you to get to this building to a net zero ready performance. And you may not have to do that before you get the incremental incentive, but you've got to know that that's what you should do. And so I think the government is scrambling to try to figure out how to do this, because they the indications we get is that they understand this and they're trying to figure it out.
Thanks, Peter. That's all the questions in chat at the moment. We also have a plug from Tim here. Tim works with Retrofit Canada. And if anyone has any questions or interest in this topic, you can follow up with the email that Tim provided. It's tim@retrofitcanada.com. And there will be opportunities to participate in future webinars and surveys regarding research into this retrofit into single homes. That's all the time we have today. Thanks for joining us, everyone. And then thank you very much for the presentation, Peter.
Well, thank you very much for the opportunity. Yeah.
And if anyone's interested in coming out to the site tour, please follow the link on your Eventbrite. There are limited spots.
Thanks again, Peter.
Thank you. Yeah.
Frank. Have a good one, everybody.
Bye.
Okay, well, thanks, Frank. And yeah, we'll see you at the tour.
Thank you, Peter. We'll see you there. Will Tim be joining us for the tour?
I beg pardon? I'm not sure.
Yep, no, I'll be there. I'll sign for
Great.
Eventbrite, but I'll help with getting people to the meeting location, and I'll be taking photos and yeah, I'll be there.
Awesome.
Okay, well, thanks again. Yeah.
Thank you.